All right, today we're going to look at graphing square root functions. A square root function is a function containing a square root with independent variable in the radicand. The parent square root function looks like this. It's y equals square root of x, and this is the graph that it looks like. Okay, it goes to the origin, that's its starting point, and then veers off in the right direction. So we can see on this particular one, our domain, okay, so this is our d value. Our domain is representing all our x values, so it's going to be everything 0 and greater. And then the range, which is the r value, which is our x. So let's see, so the range is going to be in this direction. So it's like, again, anything greater than 0, and including 0. And we're going to be looking at that in a little bit here. You can graph a square root function by plotting points or using a translation of the parent square root function. Translation just is movement compared to the parent square root function of y equals square root of x. So knowing that y equals square root of x looks like this graph, you can translate a new equation when you take a look at it, a square root one. So let's practice that out. Let's take a look. For real numbers, the value of the radicand cannot be negative. So the domain of a square root function is limited to values of x, which the radicand is greater than or equal to 0, as we saw on our last amount here. So find the domain of the square root function. Okay, the domain of the square root function is looking at the square root. So you want to look inside there. So it's going to be 3x minus 9, and we know that this is going to be greater than or equal to 0. And so I can simplify this out. So 3x greater or equal to 0 divided by 3. Actually, that is silly. That should be a 9er. A 9er. There we go. That started to look like math. So we know that our domain is going to be, x is going to be greater than or equal to 3. You would say like a set of real numbers greater than or equal to 3. And that would represent my domain, my x could be. So for the got it, you go ahead, press pause, and you go ahead and find the domain of this one. Pause. So our domain for this equation here with the radicand is, the domain is x is going to be greater than or equal to 5/2. So we can kind of start to see where that graph plays out. If our graph is here, we can see it, and we can already tell that our domain is at 5/2, and our domain represents our x value. So if this is 1, this is 2, and this is 3, we can see it's going to be starting somewhere here. Graphing a square root function. So let's take a look at this. Graph the function of I equals 1/5 times the square root of p, which gives us the current I. So this guy right here represents the current in amperes for a certain circuit with p watts of power. So p is going to represent watts of power. When will the current exceed 2 amperes? Okay, so for this one, we're kind of coming back to making a table. So we try a few different things. So we plug in some power. So we put in if the power is 0. So 1/5 times the square root of 0 ends up being 0. So we can see like this guy goes through the origin. At least this is where it starts. If we try a power of 10, so the square root of 10 times 1/5 gets us 0.6. If the power is 50, so the square root of 50 times 1/5 is 1.4. And then we try 100. Square root of 100 times 1/5 gives us 2. And if I plot this out, I can see that each point is 0, 0. I've got 10.6, 50, 1.4, 100, and 102 is the points. And I graph that out, and it looks like the graphs we've been seeing. So this is what a square root graph looks like. And so the question is, when will the current exceed 2 amperes? It looks like it's going to be right here, so above 2. So the graph continues to increase after that amount, but we can see that it's somewhere right around 2. For any positive number, in this particular case here, graphing y equals the square root of x plus k translates. Okay, so we're going to look at the translation a little bit here. You know, there's something I have noticed about graphing and translation. I'm going to kind of look at that for a moment. Take a little intermission and take a look at that. Now, when we looked at something like this, y equals x squared, that is a parabola that goes to the origin. And then we also considered the absolute value of x. And this one goes to the origin. And now we're looking at square root. And we see that this one, the parent function, goes to the origin. When we come back to parabolas, this parabola, it originally goes to the origin, but because of the -1, it goes down 1. For absolute value, y equals absolute value x -1, this goes down 1, and this one goes down 1. So all these graphs, though they look a little different, a parabola, a V, and kind of an arc, the translation is consistent all the way through each one of these. And so on this one, y equals x squared plus 2, this parabola shifts up 2 for absolute value x plus 2. This one also goes up 2. And the same will play out for this guy, and that goes up 2. I'm going to look at the absolute values a little bit more because something happens when we put it inside. Okay. Now when we do this one, that goes left 2. Well, it actually is the same for square root. If I go y equals the square root of x plus 2, this also moves my graph left 2, and I'm going to show you a couple of examples of that. But I just want to connect this with some previous learning that hopefully you caught. So, and again, if I do the absolute value of x minus 2, this is going to go right 2. Well, that's a fun way to spell right. And the same will happen in this situation. If I'm doing y equals the square root of x minus 2, this graph right here will also go right 2. Okay, now let's see this play out a little bit. I want you to see some examples of this. But there's definitely some consistencies going on. Parabolas, that's a little bit different. When you start throwing in a value for your A term, or you start getting in like a B term there, then you know like that affects your parabola a little bit more, shifting it in different directions. But with absolute value and square root, we can see there's definitely a constant pattern going on. So what is the graph of y equals, I missed one. There we go. That's the one I wanted to look at. So this guy here. So we talked about this guy. So what happens is, what is the graph of y equals the square root of x plus 2? And so this is going to translate the graph a little bit here. And for what we've seen before, this guy, because he's sitting out of the square root, translates it up. 1, 2. Okay. What's going to happen on this guy right here? Y equals the square root of x minus 3. This actually translates the graph down 3. 1, 2, oh, that's fun. 3. Fancy. Let's take a look at the next one. We talked about those. Okay, for any positive number, so I talked about this one, and what if it's inside? Okay, what if it's inside and part of the square root? And we talked about it. It shifts it a little bit differently. So let's look at this guy. So what's going to happen is when it's inside and I see plus 3, when I find the square root and the plus 3 is inside, it's going to shift it left 3. So this tells me left 3, which shows me here. And that's going to change my domain, is what it's going to happen. So my domain for this one does change. It was originally all real numbers 0 and greater, but now it changes it to all real numbers -3 and greater would be my domain. So consider the graph of this guy. And really, when I say consider the graph, just when that graph, how does it translate? So think about your answer. Okay, and this guy tells us that it is going to translate 3 to the right. That's it. All right, speaking of domain and range, I found some different ways to pronounce domain and range. Oh, this is kind of exciting. Okay, so how do you say domain in French? Listen to this.
Domain.
I know, isn't that nice? Listen to that.
Domain.
Domain. Domain. Here's the German one.
Domain.
Domain. Again.
Domain.
Domain. I think that's got some nice substance to it. And then I thought, well, what if I want to say domain in Burmese? I'm not sure. How would you say domain?